Hey, welcome back to the stream. Yeah, so last time we designed some mounting plates, or a mounting plate rather, I should say, for the Cherry ML, and a keycap for the Cherry ML switch. But unfortunately, we weren't able to print those because the printer was a little out of whack. I've since fixed that. The printer is here, as you can see it now. It's on a more stable surface. I'm eventually going to put it on, actually permanently bolt it down to a very rigid and flat surface, but I haven't done that yet. So for the time being, there it is. I did, however, upgrade the firmware to Marlin, which was a huge improvement over the default firmware, which I think was called like Omni 3D or something like that. Anyway, so printing these pieces allowed me to realize a couple of things. First of all, they came out great. The keycap itself is the dimensions are great. The only thing it didn't really come out right is that I don't know if you'll be able to see this, but the detail on the top. In fact, the slicer didn't even try to do the raised lettering. It just tried to do the embossed one. Let me turn down the music. Sorry. It just tried to do the embossed one. And now I could fix this because right now I'm using a default nozzle on the printer. It's a 0.4 millimeter nozzle. So it's a very common diameter for the nozzle. I can go down to, I believe, 0.2 is what I have in stock right now. I have 0.3 and 0.2 as well. I could try that, but if I get there, that'll kind of be the victory lap. It'll be kind of the final detail. But what I want to show you was the fact that, so actually, let's show you what it looks like all together. If I put these together, the keycap fits perfectly inside the ML. So thank you, Corey Lee, for those dimensions. It fits perfectly. And as you can see, when you smooch it down, the keycap just presses right up against the switch body, which is important. I'll get back to that in a second. I think it's a little too close there. All right. You get the idea. All right. And then the mounting plate, turns out, mates perfectly with the prongs on the bottom of the switch. I said perfectly. Yes. So it fits perfectly, which means that we got the dimensions right, and we more importantly, we got the tolerances right for the 3D printer. So it means that I should be able to kind of just replicate this pattern of holes, if you will. Yeah, I think there's 9 switches per side on the keyboard, and so I should be able to just get that replicated, and I should have the 9 switches lined up nicely, which is something I plan on trying to do tonight. It turns out that these things shouldn't be too long to print, at least test versions on the printer, so I hope to be able to do that live. Another thing that came with Marlin that's great actually is that now I've got the printer tethered to my computer. Now normally for long prints I would just print off the SD card because that's more of a standalone thing, and it's not subject to esoteric ghosts and stuff like that. Like I once unplugged the lamp in this room and the printer turned off because it was plugged via USB to the computer, and there must have been some kind of a ground problem, ground loop, ground effect, I don't know. But for short prints like this, having the tether, the USB cable, it's connected all the way around the room to the desktop that's over there. Having that turns out that it's super useful because I can just print on, or rather slice through Cura on the PC, and then just send it have the printer, the computer drive the printer directly, just as it live, and the model will come out. I don't have to eject the SD card, put the file in the SD card using an SD reader, and then put the reset the printer, blah blah blah. Now it's a lot less trouble. So on to it. Let me bring the keyboard back. Last time I mentioned that it was really cool because here you see these are the holes for the original function keys, right? And sorry, let me just. All right, these are the holes for the original function keys. But as it turns out, there are, I think the proper mechanical term is ribs. There are these little sort of plastic ridges between each hole. I don't know if you can see that in here. Yeah, you can. You can see there's like a three-dimensional structure there. Now, as it turns out, if you look at the switch, the dimension of the switch fits exactly the dimension of the hole. Like, it just fits in there like a puzzle piece. It's beautiful. In fact, I went so far as to muse last time whether Cherry had designed these switches for this keyboard. Because I know that or I read somewhere that the Browns, the Cherry MX Browns, the original Cherry switches were actually designed as a special order for Kinesis, who was building this keyboard. Now, I want to show you something that happens when you look at the other side, which is that basically, if you look at the profile of the switch on the edge, let me see if I can show you that. The keycap, you can see how it sticks out of the keyboard. Now, we don't want that. If you look here, we clearly don't want that for a couple of reasons. First of all, when you push down on the keycap, it's possible that it'll rub against the side of the keyboard face here if it's not perfectly aligned, which, is not great. Second of all, it just kind of looks, the finish looks, can I get it to focus on the right part? I'm not sure. But the finish could look, it doesn't look great. I mean, a normal keycap would kind of stick inside here. In fact, on the real keyboard, I think they look kind of like this. They stick out just about that much. But mainly, the main observation I want to bring here is the fact, so you're thinking maybe I can make the keycap thinner, or maybe I can have the keycap, kind of thicker, like it can stick inside the keyboard to prevent this gap. Well, if I take the keycap off, what's going on becomes apparent. So you can see here that the face of this switch sits more or less flush with the face of the keyboard, which is no good because I can't actually make a keycap that wraps any tighter around this part of the switch. Now, the reason for that is because of the following. If you look at what happens when I press down on the switch, it actually goes completely flush with the main body housing, which means that I can't actually have a piece of plastic on this keycap that kind of reaches down and into the keyboard, because it would butt up against yeah, this is terrible. Come on, please wake up. Oh, hopefully you get the idea anyways when I think it's this board here. That's all the high frequency detail on that board. There we go. Now if I hide it with my hand, my ugly hand, maybe it'll be better. Or not? Maybe it just gave up. All right. Anyways, the idea is I can't actually have the keycap fix this problem. I actually need to move the switch inside the keyboard, which is a bit of a shame. It's a bit of a shame, but I'm sure we can make it solid enough without that. So without further ado, I think what I'm going to do now is I'm going to try to design a base plate that's wide enough to span all the holes so that I can check the spacing between the switches, make sure everything lines up. I might actually print another keycap right away just so I have a second one to test to make sure that it lines up with the holes. So let me do that. Let me start that print. All right, so this shouldn't take long. I think it's less than a 5-minute print. And yeah, that's pretty much it. Actually, let me go back to the desktop. I'm going to use, I'm going to be a bit more comfortable to work in Fusion 360 from there. And I'm actually going to fish out my caliper. Oops. Fish out the caliper. So the printer is just heating up. That's why it's not doing anything. You'll see it kind of do stuff a little later on, probably in 2 to 3 minutes or so. All right, now as I recall, I think I'd actually measured the distance between these holes before. I'm not 100% sure though. See if I can't tilt this down a little bit so you guys can see a little better what I'm doing. All right. So the interhole distance. What's the best way of measuring this actually? I should probably measure all of them and just divide by the number afterwards, number of That'll give me less error. However, the way these ridges are set up, not actually evident to perform this measurement in a very accurate fashion. I'd ideally like sort of edge to edge, the same edge to the same edge, so I don't have to worry about the width of the hole or anything like that, or the width of the ridge itself. All right, let me wing this actually. See if we can't get it right. I mean, all right. I'm gonna line this up with edge to edge. That's pretty much exactly 112 millimeters. 112 millimeters, right on the nose. All right. Divided by 9. So, all right, let me switch back to, oh, the printer should start any moment now. There we go. I'll move the camera over so you guys can see what's going on, and I'm also gonna switch microphones and stuff like that so it's not so loud. All right, here we are. So I said 112 millimeters, right? Excuse me, I'll be right back. Sorry about that. All right, so 112 millimeters. I could call that all key width, maybe. Key tray width. All right, and that is the total width. So now, if I went and I said quickly, I'm just gonna check that it is 9. One, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9. All right, perfect. So that's 12.4 millimeters per little cell, if you will. All right, so can I actually, I'm not sure whether I can, let me check something out. I'm not super familiar with the rectangular pattern objects. All right, so can I mirror it all? Well, not mirror, but all right, so this is it. Then directions, I would like to select this direction. No, can I select that direction? Can I display the origin? All right, extent, spacing. No, I want extent. Quantity, I want 9. Suppress, what does that mean? Suppress. All right. Ooh, this is starting to look promising. Oh, I see. Okay, yeah, okay. So I don't need to remove any of these, or any of these. You can check them in and out, you know, to decide whether you want them. So like this, for example, I can decide I don't want that one. All right. All right, so let's see what's going on here. From here to here, that's 124. That's a little too much. I think that's because when you pattern, it actually is from left edge to left edge, if I'm not mistaken. Nope, not even. What's it doing here then? Where's the pattern? All right. 9. Okay, wait. 1, 2, 3, 4, 5, 6, 7. No, that's 9 total, so it's not adding 1. Wait, sorry. Yeah, this is the width of, sorry, the 112 millimeters is the total width of the plate that I want. It's not the width of the switches, because there's this little border here, or the width of the width from edge of the switch to edge of the switch. What I want is for this rectangle here. Can I actually try that out? Did I dimension that? No, I did dimension that somehow. So I've got this being 12, this being 2, this being 2. Okay, this one I'm going to get rid of this dimension. Alright, there we go. And now I'm going to instead, dimension this. Oops, sorry about that. Like this to be key tray width. Alright, that gives us a better idea of what's going on here. Huh. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh wait, I know what's going on here. I know what's going on here. I've got this wrong, unfortunately. The way the switch mounts, if you look at it, let me switch back there for a second. Yeah, okay. Yeah, alright. I know this is fixed focus, so it won't come out great. But the switch here, when you look at it, let me pull up the data sheets. When you look at it, it's not symmetrical. So this part, this here, I actually designed it so that it would go sideways in the keyboard. That's the only way to fit these close enough that they'll actually line up with the holes on the keyboard. So the 12 millimeters I've got here, that's the height of the mounting plate. You can see the keyboard would effectively run down vertically here on this page. Like there would be a switch here, and another switch here, and another switch here. So what I need to do in Fusion 360 is, first of all, I need to get rid of this guy here. Oops, that's not what I wanted. Okay, wait. So constrain this design. I see what's going on. Can I actually... Nope, it won't let me do 0. Okay, then 1. Okay, awesome. Now I can get rid of this. Boop. Alright, so this is the dimension that's 11.4. So I actually need this board to run down like this. Now, what I could do is... Okay, let me put back this dimension here. Can I actually rotate all of this in the sketch without screwing everything up? Yeah. I think if I use this move, it does work. Sketch geometry to move. Alright, X angle. What's this? Z angle. Alright, 90 degrees. Let's try that. How does that look? This doesn't look too bad. Looks pretty good, in fact, if I may say so myself. Alright. So now let's get rid of this. Let's say dimension this along with this guy. And now we have it. Alright, that's more like it. So, the size of this square is a bit arbitrary, actually. That's the footprint of the switch. But that doesn't mean that each switch is going to take up this amount of space. Now what I should do probably is I should actually just cut that out. Okay, I know what I'm going to do. So I'm going to make a rectangle here. And then this guy is going to have key tray width divided by num keys, which is not correct. What is num keys? Num keys 4. Well, that's wrong. All right. And now, okay, this I can get rid of, this dimension. Now moving it up and down is no good, but can I move it sideways? That's not quite what I wanted to do. Constraint solving gone wrong. Let's make this vertical and horizontal. Why is this? I've got something crazy going on here. Alright, this dimension here I can get rid of for now. I just want this to move freely. There must be some kind of a dimension still. Ah, yes, there we go. Alright, there we go. Now this should move freely, more or less. Why is it not moving left and right? It's not moving left and right because there is a dimension here, which is the size of that rectangle here, but this shouldn't. Oops. Why? Oh, there we go. Okay, that's not what I want either. Let's make this perpendicular. Doop. Alright, now I can move this. Can I move it up and down? I can. Alright, so thus begins a precise positioning operation. Okay, now what I'm going to do is I'm going to try to rectangular pattern this feature. Could I actually have done this one? Let me try that. Okay, wait. Let's try this. Rectangular pattern this by key tray width. That's the extent. Now I want 9, or do I want 9 or 10 here? I want 9 gaps, but 1, 2, 3, 4, 5, 6, 7, 8. No, I want 10. Oh, that's perfect. Great. All right, I'm actually going to get rid of this one. Oops. Okay, so I did. Okay, so now I've got the one that's part of a pattern that's in there. This is great. Oh wait, the printer finished. Let's go see what's going on. Oh, got a bit of a plastic blob here. Oh, I know what that is. The printer kind of just idled there for a short amount of time. I shouldn't have left it go unmonitored. All right. So if I clean this up a little bit. See, there's support right now in there. Looks a little bit like a cinnamon bun or something. Everything but the 2 central pegs there needs to be cleaned out. But it's pretty easy actually, because it's the software makes it so it's very easy to snap off. So, let me just try to get in there with a knife. There we go. It's just popping right off. That's the outer shell going. And then I'm going to try for the next one. And there it goes. Now the reason I printed this with the support is because I wanted to try to see if I could get the printer to finish the top side with the hot end, as opposed to having the top side of the keycap be face down on the print bed. Now some people like the finish that the print bed gives. I don't mind it personally, but I'm lucky enough to have a printer that I really like the top side finish. I think it just looks like nice and mechanical, and it looks nice, I think. I just like the look of it. So I figured, hey, if I could print these with the legs, the pegs kind of downwards, then I'd get the nice finish that I liked on the top. Now it may be that I have to kind of switch strategies and just get the sorry, this is kind of, you know what, maybe I'll clean this up a little later on while I've got a test base plate printing. Let's do that. All right, so I'm just gonna yank once more there. There we go. Oh, nice. This one came apart nicely. All right, we'll finish that a bit later. Back to 360. All right, so did I lose my music? Ah, retry, please. There we go. So now I'm going to take this, I'm going to try to center this design in this square. Now to do that, what I'm going to do is I'm going to sketch a point right in the middle here, and I'm going to sketch another one there. Alright, and now I'm going to sketch a line right down the middle here, and I make this a construction line so it doesn't actually partition the profile. Oh, what's going on here? Oh, wait. Let me try something here. Okay. If I hide these bodies and I try to extrude something. Oh, this is not actually dividing up the space. Is that a problem? These lines are kind of wow, this is weird. I've never seen that before. Well, it's the first time I tried to use this pattern tool to create these lines. Now I see that it snapped the lines, these vertical lines, the dividers to the top and bottom edges, but it doesn't appear to be dividing the profile up. Like this is one huge profile, which is kind of weird. All right, I don't think that'll be a problem later, but I guess we'll see. Always time to learn. So there'll also be the question of vertical spacing here. But what I'm going to do for now is I'm going to say that this guy and this guy need to be coincident. Aha, now we're in business. So now the switch is exactly centered inside this hole, which is good, which is what I want. I just have to figure out whether it needs to be higher or lower or what's going on here. Woohoo! Okay, that's not exactly what I wanted. I think, okay, you know what, let me back this out. Instead of going with this pattern here, I am going to go with the original approach that I had, which was to say that I had a rectangle. I'm going to try that. I get rid of this point and this constraint. Oh, it does this sometimes. I don't know why. Oh, this is the old rectangle that I drew. I suppose what I could do though is instead of having this big rectangle here, I could just get rid of the whole thing. Let's get rid of the whole thing. Yeah. Okay. Now let's make a rectangle that is whatever. Was it 12 millimeters high by or say whatever 16, doesn't matter, by key tray width divided by keys. All right. Okay, now I've got a proper rectangle. Now what I'm going to do is I'm going to actually rectangular pattern that. This guy, like that. Now I'm going to say 9, and I'm going to say 112, which, see, what am I doing wrong here? And by num9 I mean num keys. What am I doing wrong here? Is this the cumulative width of 1? So there's one thing I don't understand about extent. Actually, you know what? Let me do spacing. And then let's do num keys. Oh, sorry. Key tray width divided by num keys. There we go. Now I get the exact spacing I want, and if I measure this, I'm going to get 112. Yeah, there we go. Okay, awesome. Perfect. Now this is an actual profile. You see when I mouse over them, they're separate, which is good. And I can, yeah, okay, and now there's a constraint, which is perfect. Now I can go and divide this guy up with a construction line. And I can line up this point with this line. So now I can move this up, and this side to side will move everything with it. Okay, now I just need to look at the keyboard again and see if I need any measurements in terms of sort of top to bottom there. So let me look at the keyboard here quickly. I've got it here on me. I'm going to go and say that, man, it's full of angles. I expect I'm going to have to iterate on this quite a bit, actually. Full of angles. Weird, bizarre angles. So what would be cool, actually, would be, we know that this switch fits exactly inside those ridges. So what I could do is I could kind of extend the profile of the switch and then make it so that, because I can't have the switch actually dock in that hole, as I explained earlier, it sticks too far out into the keyboard. What I could do is I could have the base plate, though, the mounting plate, be fixed between these ridges. I think that might be interesting. Okay. All right, so let me just really quickly there try to see how much of it's actually asymmetrical what I have. Oh, and it's not even the same dimension across the whole row of keys. The whole thing is curved, so okay. I've got something like 1.2 millimeters. There we go. That was a very poor measurement. Kind of eyeballed it. All right, so 1.2 millimeters. Let's see what's going on here. 1.2. There you have it. So now, in theory, all this moves together, which it does. Now, I said it would be nice to have this bit kind of protrude out a little. Now, can I extend the sketch? I believe I can. There we go. Constraints were removed. Okay. Can I still move this though? Yeah, this is kind of wrong. I'm not sure what constraint it decided to remove, but it's one I clearly cared about. Okay, wait. This all moves together. Can I actually move this? Oh, I can. Okay, there's something that's unconstrained here. Okay, that's what's going on. Okay, can I constrain this? If I try to move the circle now, okay, everything moves. This is what we want. Okay, so some of these are, yeah, Fusion 360 is a little weird that way. Sometimes it'll solve properly. Like I can move the square and it moves the circle. Now in theory I should be able to move the circle, but it doesn't. It should be able to move the square. You see it like kind of moved a little bit there. Oh darn, darn! These are off kilter again. That's wrong. Okay. Oh, I see here what's going on. Okay. Okay, this looks better. Everything's staying true. And it's moving the bracket around with it. Okay, this is good. Let me save. Maybe nice time to save. Okay. So I could actually create these lines here that kind of by hand, instead of using extend, it seems to be less offensive. And I could have this profile here that would jet out a bit more and brace against the keyboard. I like that. All right. And then another 2 millimeters, let's say, underneath here. Oops. Can I actually, let me move this dimension out of the way. Let me move this one inside. All right. Clear the clutter a little bit there. There we go. This. Okay, so now if I move this, it all moves together. Awesome. All right. We're getting somewhere. So I think all I want to do now is I'm going to rectangular pattern this stuff. I do. I need the holes. I don't need this. I do need that. Sorry, I need the holes and the little things are going to protrude. So these parts here. I'm going to say again, spacing is going to be key tray width. Whoops. Divided by num keys. And I say 9. And there we go. Now it doesn't need suppression. Starting to look like something. All right. So now if we stop the sketch and we extrude, oh, there's going to be a lot of profiles to select, but there you go. So here's something. See what I could do is I could actually extrude one of these, and then I could mirror it across. I could have done that instead of patterning this sketch. I could. In fact, you know what? I'm going to do that for now. So now this is a bigger plate. Distance 1 millimeter. I'm going to show the sketch again. I'm actually going to extrude this guy and this guy. Whoops. This guy and this guy. Whoops. Further out, I'm going to join, and by a distance of say 2 millimeters. Well, depends how much I want to push the switch back inside. Let's say 3 actually. Okay. Join. All right. Looking good. I think I might have some problems with some tolerances here. Okay, I'll get back to that. Now what I'm going to do is I'm going to take this guy and pattern it. directions. Okay. Spacing, quantity 9. Distance. Tray width. Yeah, that's wrong. Divided by 9 keys. Direction. Okay, now all of these are separate, but I believe if I go like this, can I select them all? Dot, 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 dot. I can join them. And then now I have a problem because they don't join. Okay. What if I try to join just 2? There's some kind of a tolerance problem here. I think that might be my issue. Join. Yeah. Yeah. Wait, sorry. Keep tools, no, okay. So what if I change this pattern just for fun? And I said -1. There we go, just like that. Just to make sure they overlap. And then I actually try to combine them. So this guy and this guy, join. Yeah, now it's joined. Okay, so it's a tolerance problem. So that's a reason, right, why maybe I don't want to do it this way, though I suppose. So I don't like doing this, but I suppose I could subtract like a very small value here just to make sure they overlap, which is really a shame. So that adds up to what? Over 10, that adds up to 1/10 of a millimeter. But if I select them all now, they join properly into one body. So it's a tolerance problem. Well, fair enough. I suppose I can deal with this for now. This doesn't look too bad. Okay, now I think I'm gonna have a problem with the size of these little nubbins here. Because the printer is going to print them a little bigger than this. So I actually need to go inside the sketch, and then instead of mirroring, well, okay, let's forget about the mirroring for now. But what I need to do would be to offset actually can actually offset the full curve, like chain curves, sketch curves, 2, 3, and I can't, it won't let me select this curve. Okay, that's weird. Because there's something about, it figures out that there's something that doesn't work. Let's try, if I try this one first. Ah, I see what's going on here. Okay, so there's no line from here to here. It just sees the full segment. That's what's going on. That's what's going on. Oh, wait. I could break this, I believe. Yes. Now, do I want to do that? I'm kind of afraid. Ah, see, it broke it even at the construction line. Oh, wow. Okay, that's pretty intense. But now, if I offset, I bet you it'll work. Or not. Okay, screw this. Forget about that idea. I'm going to simply draw a rectangle here and offset it by some value that I'm going to configure. All right. Let's call this rib ridge tolerance, because it's the ribs inside the keyboard and this is a ridge. All right, so let's say it's 0.2 millimeters, and then we'll just rib ridge tolerance, rib. Really, what's going on here? How is that over constrain the sketch? Okay. What's going on here? Oh no, I fall into like dimension hell. Oops, that's wrong. Rib ridge tolerance. Rib ridge tolerance. Move this here. And now this one. This I don't get. This I can move. And now, okay, rib ridge tolerance. Okay, now it's that worked. Okay, so I must have misclicked or something earlier. This makes more sense. And then same thing here. Draw the same thing there. Rib ridge tolerance. Whoops. What's going on here? Rib ridge tolerance. Whoa. Please delete or modify one of the following. Okay. It's getting antsy. It's getting antsy. Rib ridge tolerance. Oops. Oh, what happened there? What is happening here? Let's save this before I screw it up. Okay. This just didn't solve the way I expected it to is all, but it looks okay. So it's freaking out now. I can't move this at all anymore, which is weird. I should still be able to. Nothing here is fixed. I can tell that it's on the verge of blowing up. Luckily, I don't need to add that much more to this sketch. Okay, and now I'm going to edit this operation here. Sorry, it's the next one. To select the new profiles. Like this. Like so. There we go. And then, oh, what's going on here? Did it stop patterning? Edit feature object. Oops. Oh, wait. Sorry. What's going on here? Shouldn't be new body. This should be join. That's what's going on. Okay. Alright, so now we've got a bit of a tolerance here between the pin and the ridge. That is good. Let me look. That is quite good. Alright, and this ridge should fit within the other ridges in the keyboard. So what I'm tempted to do now is to print two of these, just two of them, and see what's going on, if the measures are right, if it'll fit inside the keyboard and everything. And so in order to do that, what I'm going to do is the following. I'm going to create a box. Am I even going to align it with anything? I don't really need to. I'm just going to cut this off right here. and just subtract everything. There we go. All right, let's say this is an STL. Okay, PCB, blah, blah, blah. Then I'm going to come in here. I'm going to slice that up. Kinesis, Dropbox. Oh yeah, sorry. There we go, and then I'm just gonna make sure that this is rotated properly, like that, and I prepare for fun. You can see the layers, what's it gonna do. Oh, 9 minutes, that's a lot. I want to spend 9 minutes. Let me print this in a slightly coarser quality. Infill, I don't really need a lot. It's not going to infill anything anyways in this print. It won't make much of a difference. And then I'm using the black PLA, so that's actually the one. Let me quickly heat up the two, both actually. PLA, PLA. There we go. Okay. 205, that looks great. Perfect. Now if I reslice, it should be like 5 minutes, 4 or 5 minutes. 6 minutes? All right, fair enough. Okay. I think we have a winner. I'm just going to print this. Oh wait, sorry, I opened the wrong folder. I want the STL, I want the G code. All right. Download, blah, blah, blah. Oh yeah, load and print. That is what I want. All right. So 6 minutes is what it should take. Should start any moment now. I think the problem is the bed is a little... Oh no, there we go. Sorry, the temperature is a little too high. Or not, sorry, not high enough. There we go. There we go. So now you can see the printer doing its thing. I'm going to go back over here. All right. So what's going on? We've got a visitor. All right, so I'm gonna keep cleaning this up while I wait for the print to finish. Yeah, it's going well. See, that's the cat is getting hungry. I don't think I'm gonna stream too late tonight. Maybe after this works, I might just actually try to let it print the full one full row of like a full mounting plate. There we go. Nice clean keycap. Not too bad. Let me see if this fits. Awesome, I don't even remember which was which. I think this is the new one. I'll try both. Aha, see, yes, this is a new one because it doesn't quite fit. Why doesn't it quite fit? I think maybe the difference here is I had a slightly, the printer head maybe was a little closer to the bed, so the plastic, the first layer got squished a little tiny bit more. There's a bit of an elephant's foot is what this is called. And I think that's preventing it from entering the, almost. Yeah, this one fits really nicely. Oh man, it's a matter of like microns, holy cripes. Yeah, microns, alright. So I might actually break this keycap unwillingly. Or maybe I could use sandpaper. Actually, sandpaper right here. Oh, what a coincidence. How's the print looking? Print's looking good. All right. How's it fit now? Come on. Still doesn't quite fit. Yeah, neither leg. Oh, that's not true. One leg fits. You can see I can kind of fit it in like sideways, like this, misaligned. But the other leg, the other prong doesn't fit. But I might do oh, it does kind of fit actually. Okay, so maybe they just don't fit together, or they don't fit. Oh, they do. All right, there we go. It was very, very, very close to fitting. All right, got a second keycap. Let me get a second switch. Obviously, this is not the final keycap design. I'll be cleaning it up and probably, you know, figuring an easier way to print these without having to clean them all and everything. And I might make them thinner and stuff as well, but for now I just want to be able to check the alignment. Oh, I like the way this is looking. I like these keys. This is the life. Oh man, I cannot wait to have this working in the keyboard. Oh, this is gonna be so awesome. Oh. Man, these rubber dome keys, such garbage. I mean, from day one, I don't think anybody likes them, but especially when it's like this stochastic process and you push it, and sometimes it pushes, it like activates, and sometimes it doesn't, and sometimes it activates 700 times. Oh, I have to use sticky keys now in Windows. I have a special registry file that I carry with me so that when I push my function keys, they don't register 7,000 times. Because, you know, if you're debugging, it steps over like 10 breakpoints or something like that at once. It's no good. But with these babies, oh, this will be great. How's the print looking? The print is looking good. 2 minutes left. All right. Oh, this will be cool. Oh, I cut myself. See, right now it's printing the ridges. You can see it's making a different noise. it's printing the little ridges there that are supposed to fit inside the keyboard. I think it's almost done actually. So 90%. Less than a minute. Almost there. This printer, by the way, it's an ANET A8. It's a very, very inexpensive printer. Here in Canada, I think on sale you can get it for, I think I paid $198, $197 for it, Canadian, which then needs to get shipped and dutied, which I think for me total came around $230, which is incredibly cheap. It comes in a million pieces, obviously. You get to put it together yourself. You kind of need to know what you're doing. There's a lot of DIY involved, but it's an amazing project. I really recommend it if you're at all into 3D printing. It's a lot of fun to put together and to play around with, and there's just so much room for upgradability. A lot of these parts are parts that people designed online. Everything is blue. Let me just make sure here that there we go. Yeah, it's tremendously upgradable. I have a auto level sensor for it that I'm going to retrofit soon. I printed the mounts the other day. There we go. All right. Will this work? We will see soon. Let me just take this off the printer. Oh, this is looking good. Check this out. Check out this template. Looks nice. Nice and snug. Just the way we want it. Look at these ridges. So 3 millimeters may be a bit much. We'll see. So, moment of truth. First of all, does this fit in here? Does it fit? Will it blend? Oh, it fits perfectly. It fits perfectly. Well, I mean, so for the axis that I cared about there, I didn't look at the vertical axis quite a bit, because I mean by vertical I mean the axis that's like this. I didn't look at this dimension so much. I just wanted to make sure that everything fit nicely within the grooves, and it really does. It's nice and locked in there. I mean, it could be a little tighter there, maybe just a little. All right, but let's see what gives with these switches. Oh, this is exciting. This is exciting. Oh, it looks like the switches might not fit though. Well, I could be wrong. Do they fit between the ridges? Do they fit between the ridges? What's going on here? Oh, this is great. Check this out. Check this out. It's perfect. It's just tight, just the right amount. All right, I'm going to catch you this time. I'm going to show you on camera, unless you run away. No? Are you running away? Oh. I found my helper. My helper. It's my lab assistant. Nuba. There you go. Yes, you will be fed very soon. All right. I actually need to grab my sulfite. There we go. I have a polar fleece shirt on. I don't want to fry anything in my keyboard. And let's see if I can't fit the second switch here. Oh, I like the look of this. I really do. Oh, I have a bit of a problem here. I just need to clear out this hole. A small, minor, like print defect. If you look at the hole here, there's a bit of an obstruction. Can you see that actually? It's this hole here. Anyways, there's a bit of an obstruction there. I'll get rid of that. If you do have a hand drill, I'm not sure that it's appropriate in this case. I think I can just use the knife to ream it. Meh. There we go. All good. Now, I've got a second switch. Oh. 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 This is so cool. This is so cool. Oh, this is going to be awesome. All right. Now let's see if this lines up properly. Oh, man, this is awesome. Lines up great. Now let's see from the other side what does it look like. Yeah. Oh, look at this. Okay, so it's not... what's going on here? Because I think I need to be a bit more... Okay. There's some parameters to tweak here, clearly. Oh, but I really like the way this is looking. The feeling of these switches is just amazing. Oh, this is great. Oh, I love this. This is so encouraging. Okay. And see now, I've used the ridges to kind of sink the keycaps a little further back in. So now the switch is not so close to the faceplate anymore. It still is a little, though. I think I need to make it a little more... I still think I need to back that up a little more. Oh, man. Oh, man, this is so cool. All right. Let me really quickly there try it from end to end. Oops. So it works at the end. Does it work at this end? It most certainly does. Oh, and the feel here is so good. See, what's going on here is because the keyboard's curved. So here at this point, it's actually, the faceplate is hot. It kind of eats up part of the keycap. Now I can get a feeling, kind of a preview of the feeling, what the feeling will be when the keycaps are sunk a little bit in further, and it feels great. I mean, this feels, I mean, if it wasn't for like the little ESC that's printed there, this actually feels like something that's like factory made, you know. It's really nice. I mean, a large part of that is the switches there, but yeah, wow. All right, so I'm at a bit of a crossroads here. It is 11 o'clock. I had to get up at 5:45 this morning, and I had a very long day. I'm actually just out of an illness as well. I'm on antibiotics right now, so I think I'm gonna need to get some rest and sleep before tomorrow. But this is super encouraging. I'm very glad to see this progress. I think some of the next steps are going to be obviously try to scale this up. I might do the scaling up offline there. It's just going to be waiting for a print for the full size gizmo. I think we have a proof of concept here that's quite solid. And then maybe just adjust a small dimension or two there, something very, very slight, just to make the tolerances just a little tighter, especially when it comes to fitting this base plate into the keyboard. But then after that, oh, I'm super happy with this. You can see that here we still see the pins from the switches. You can still see them on this side, which means that we have some leeway to go there in terms of PCBs and stuff, in terms of being able to solder to the underside. Man, I gotta figure something out about this focus. Yeah, and I mean the mechanical strain relief there with these plastic pins is great. There really isn't much I can complain about this. Wow, I'm super jazzed. All right, I can't wait to keep going. The next steps will be, so next steps will be printing the whole thing, and then probably the next time I'm on air, what I'm going to do is I'm going to look at the original circuit, these flexible circuits here that are part of the original keyboard. You may remember, these are the circuit boards that were, flexible circuits, I guess, that were in the original keyboard. Now I need to replicate this logic to so that the keyboard can read the switches properly. It shouldn't be too complicated, actually. All I need to do really is kind of trace this out. Oh, but I see that there's a lot of traces here. I'm worried about those tolerances for the printer. We'll see, I guess. We'll see how big we can make this PCB. But hey, another day, another challenge. So yeah, thanks for tuning in. I hope you enjoyed it. Next time will be about some electrical stuff, I guess. Have a good one, and be well.